All right, I would like to record a video that kind of is a partner video of the kind of how to operate the SEM on the 8th floor with how to perform EDS, energy dispersive X-ray spectroscopy for chemical analysis. So I'm going to go through the software and kind of show you the buttons and what they do. To start off, before you do EDS, you have to load your sample into the microscope, right, and get it focused and everything. So I already have a sample in the chamber here. It's a little puck in there, and it is at a very specific position, which we will see. But right now, I'm going to turn the gun on. Okay, we see some features, see some bumps. This is a metal alloy, so we have some different phases present, which help us with EDS for good composition measurements. So when you put your sample in the chamber, you want to get it focused, and you want to be at a specific, around a working distance of 15 millimeters. So here is the inside of the chamber. Our X-ray detector is this kind of pencil looking attachment here, and it is fixed in position. So in order to get good EDS data, we want to raise our sample up so that it crosses our EDS detector. And the way it is installed, this position is at about a WD of 14 or 15. So when you're focusing your image, you want to raise your sample and you want it to be in focus at a WD of 15. Now this works well anywhere from like a WD of 10, a working distance of 10 to 20. So it doesn't have to be specific, but the closer you are to that 15, the more efficient your data collection is going to be, okay? So I'm at about 15.8. There is a setting right here on the stage control called WD and Z. This allows you to set it so you are focused at a specific working distance. So right now, I'm focused at a WD of about 15.88. And if I go ahead and type in 15 and hit enter, it will move the sample and adjust the WD at the same time. So in reality, you can get your sample focused at really any Z height, any WD, and then as long as you go to this WD and Z and type in 15 and hit enter, you will you can go to that specific proper Z height. Okay. All right. So I've got some small features here, so I'm going to zoom in so we can see some features. All right, we'll go look at this guy here, since we have some light and dark phases. These are different elements, different elemental bases, and I'll play with my working distance, try to get that pretty good. All right, my stigmators seem okay. I'll look at the column alignment. There's some slight up and down motion, so I'll and fix that using the trackball. There we go. And then back to working distance, see if I can get it just right. There we go, that's pretty good. So in order to get good EDS data, you need to be in focus because it collects it from where the beam is at. So once you're in focus at around 15, we can then go to the EDS software, which is on the secondary computer to the right. So I'm going to pick up my camera and we'll move to the side. There we go. All right, and you will have your own unique UT desktop, right? But what you're looking for is this program, Esprit version 2.3. So you're going to go ahead and click that. The username and password are both EDX. You should not need to type these in. You can just hit log in. It is important that the microscope is on first. The Vega software is on first before you open this, because this program talks to the Vega. So if the SEM is not running, it will not be able to pull data from the SEM to give you accurate working distance values, which you see here in the top. This guy right here. Right. Try to adjust this so it's mostly level. Slight, there we go. Oh, that's a little off. There we go. That's okay. Okay, so in the EDS software, there's a few things here. We have any sample name. If you want to name your sample, say you're working and you're going to take a bunch of compositions, right? You can name which sample it is. We have the microscope conditions, the working distance, the magnification, and the accelerating voltage of our beam. I have it set at 30 kV right now. We have kind of the scan type, the resolution, how many pixels, you know, and the dwell time and things like that. So you can increase the dwell time, you can average lines if you would like to play with those, right? And then we have the spectrometer, this box here. This box is critical, and this box contains a value known as the dead time, and also the ICR, the internal count rate, counts per second. So these are the number of X-rays we are collecting per second in our detector. And if I zoom in, right, you can see right now we have an internal count rate of 94 kilocounts per second, and we have a dead time of 7%. This is not accurate for the moment because the infrared camera is on. The IR camera is actually detected by the EDS detector as X-rays, so it slightly skews our values, but it turns off when we take a normal scan, so it's okay. I'll turn off the infrared camera on the SEM, and we see our internal count rate has dropped quite a bit. It's now at about 8.8 kilocounts per second. So there's that. So when we're collecting X-rays from our system, we want to have a good X-ray count. And I'll start a scan right now just to show you. You have your scan options are these four buttons here on the left, right? These guys. Right, we have a simple spectrum that says whatever the electron microscope is looking at, right, whatever's on the view screen is what it will take compositions of. Right, we have an object scan, which will say allow you to select regions of your image, say like a point, like a pixel, or something like that to select it. We have a line scan, which is a series of point scans along a line, right? So this is good for layered samples. And we have a color map, an EDS map, which I'll go. So we'll start with a simple spectrum, right? When you have selected which option you want, we have these buttons up here, acquire and quantify. So we first need to acquire our spectrum. There's a little drop-down arrow, right? And in here we can set the measurement conditions, right? You can set a automatic, which runs for a set number of counts. You can do manual, which means just collect X-rays until you hit the stop button. Most people operate in a real-time condition. This is the number of seconds your scan will run before it stops, so that you define it in seconds. We'll go ahead and do a quick 30-second scan. There's also live time. That is the way, it's a slightly different clock for the detector. It tends to be slightly longer than real time. I'll talk about it in a second. And then you can also run for until you get a certain number of X-ray counts. There's some few other values you can play with quantification, acquisition, identification, things like that. But for now, we'll just run a real-time scan for 30 seconds. And once we're happy, we'll go ahead and hit acquire. And I'm going to delete these old. So the old spectrums are listed down here at the bottom. There's a little red X on the right here, which you can delete old scans. All right, and here is our spectrum, okay? If you right-click on the spectrum, you can do automatic scale, right? So you don't have peaks going off the screen, right? This guy's a good scale. And our timer is up here on the top right, okay? So our timer just ran out, 0 seconds, so the scan is done. So we have a spectrum. We don't know what these elements are. So in this, there's a button here on the right side, right? Which is the periodic table of elements. There you go. And then from there, you can add and select elements as you wish, or there's a button down here that says Auto ID, and you can go ahead and hit that, and that will identify our elements present, right? And if you do this little drop down, you can define kind of the minimum concentration, or if you want it to ignore some elements, you can deselect them, right? But this is kind of more specific. So we'll do Auto ID, and we see after hitting Auto ID, right, we have copper, we have silver, we have some carbon, That's pretty much always there. And then here's our spectrum, right? From 0 to 20 keV. Okay, so we're happy with those identifications, but we would like compositions, right? We actually want quantification values. So after we do that, after our spectrum is done, we can go to quantify. You want to open this dropdown and you want to hit interactive mode. All right, you always want to do interactive quantify, not automatic. Then we go ahead and hit quantify. It opens up this window. I'm going to open the whole thing. All right, so it has our spectrum here. Right? It has our compositions here. Depending on the conditions, it's always best to help set the background for our system. So we need to, in this button here, you see there's a background settings. So when you bring up this quantification window, you want to auto ID your elements again to make sure everything's identified, right? You then hit auto to set the background for our system. And then from there, we tend to, the numbers tend to be more accurate. So we hit clear all, auto ID, auto background, and then our quantification, our values are in this little dropdown, okay? So from here, we can see what elements are present, right? We have carbon, we have copper, we have silver. They give us the elemental number, the primary line peak it is identifying, and the mass percent, right? The normalized mass percent, if you did not have 100%, right? If you're missing some elements or you've subtracted some elements from the system, you can normalize it to 100%, or the atomic percent, right? So really, these are kind of what we would record and write down, okay? If for some reason you would want to ignore an element on the periodic table here at the top left of the screen, right? We can add and subtract elements from our system, right? Go. We can add and subtract elements, right? And it recalculates for us, right? So initially we see right here, we have 2% carbon, 63% silver, 33% copper. If I deselect carbon, right, it now shifts to 65-34. Right, so it recalculates for us. Okay. Here is a good chance to see if any of your peaks are misidentified. So if you look at the periodic table, you can left click and drag and change the scale, right? You can drag around here. If you scroll the mouse wheel while on the plot, you can expand along the center point, right? Wherever this you left click wherever you put this guy here. Or if you want, you can always write on the button here on the right is little a, that's your scale, so you can return it back to what you want. If for some reason you can't identify an element, say we have a peak and we're unsure, right? Say we did not identify carbon, right? We have this, or copper, we have this very large peak and we're unsure. If you left click and put your mouse cursor on that line right at your middle of your peak on the left here, you see an element finder. And it tries to predict the best element possible for that. So if we look at the element finder window, right, we see our top suggestion is the copper element, right, followed by tantalum, and a few other elements as well. So using that element finder, right, we can then go to the periodic table. All right, we can go ahead and add copper, and we see it matches, right, very, very strongly, right? Our second option was tantalum, so if we wanted, right, we can go ahead and add our tantalum, and we see, right, if we were to zoom in, right, we see the tantalum peak does not match very well with the copper peak, so our best option is still going to be copper. So auto ID, right, we hit this on the top left. It works pretty well, but it's always good to do a nice sanity check to make sure everything's good, okay? All right, so let's say we're happy with this data. We would like to save this data. There's this button you see here on the lower right, the little back and forth arrows, right, that you see there. that is the kind of universal save button. And you will see that on a bunch of different areas of the software, right? If you left click this guy, the results, you can do a few things. You can save it, right? As if you hit save, it'll bring up a window, right? You can save it as an image. You can save it as a text file or an Excel document. So you can save it like that. My general recommendation is you use this button and you add it to a report. Right? Now what this does is it puts it into a Word document, and every time you add something to the report, it just builds it in that Word document. So I'm going to add this to the report. I will also, you see there's another button up here, I will add the spectrum to the report as well. Okay, I'm going to go ahead and close this window, right, to go back to the regular screen. There we go. And in this box next to the spectrometer is the report window. And if you open this drop down, you will see the report. So here's our composition, right? Here's our spectrum. If I close this, right, I can add this spectrum to the report, right? Because we have this arrow here, right? I'll add the spectra to the report. There we go. And then if I open the report again, you now see there's a new page with our spectrum on there. Okay, once you're done, once you have completed your system, right, you can modify this, you can type in values, you can delete data if you would like, but there is another back and forth arrow in the report page, and then in the report you can save it or export it. And then from there you can export it as a PDF file or a Word document, right? Or you can also save it as an image. It only lets you save it as an image, which is not great. So generally I would export it from there. Okay. All right. So I did that spectrum. We'll see our tallest peak, you can see on the left here, is around 18 counts per second per EV, so it normalizes. So this is where we talk about dead time, right? So dead time, this center box here, you see it's at 5%. We have a count rate of about 8.6 kilocounts per second. Dead time is a ratio. The way the detector works is it can collect an X-ray and it can count an X-ray, but it cannot do both at the same time. So what dead time is, it is the ratio of collecting time to counting time, right? Low dead times mean that you are collecting few X-rays and you're spending a lot of time counting those few X-rays. The EDS detector operates right at around 50%, where about half your time is spent collecting and about half your time is spent counting. So generally for dead time, we want to have higher dead times than 5%. The manufacturer recommends dead times around 40%, but I would say anywhere from 10 to 50% dead times are good. So how do we change dead time? We change the X-rays coming from our sample, right? So to increase dead time, we need to increase the number of X-rays we are generating. To decrease dead time, we need to decrease the number of X-rays, okay? So how do we increase X-ray count? For that, we need to go to the SEM, and we have a few options for increasing dead time. Right, we can, if we zoom in on the microscope settings, right, we can make sure our sample is at the proper working distance, right, so we can control the Z height with the stage control. The two main ways to increase dead time, assuming you're focused, is you increase the accelerating voltage or you increase the beam intensity, the beam current, the beam diameter. So larger voltages and larger beam intensities will generate more X-rays. Right now we're at a beam intensity of 10, right, which is right in the middle. It goes from 1 to 20. And our X-ray count is at 8.6 kilocounts per second. Okay, so I am going to increase the beam intensity, and we can see how our dead time changes as the beam intensity increases. So right now I'm at 10. I will go to a beam intensity of 12. Right, we see the dead time does not refresh until you start a new scan. So I'll go ahead and hit acquire. So we went from a dead time of about 5%, now we're at 13. All right, let's increase our AlGoa beam intensity to 14. Okay, our dead time is now creeping up. All right, now we're at about 20%, and our count rate, if you can read that at the top, we've gone from about 8,500 counts per second to 55,000 counts per second. You see our spectrum now is quite a lot higher. Our highest peak before was at about 18, so right about here, and now our highest peak is sitting at about 70. So not only does higher dead time make your scans run faster because we collect more x-rays, right? It also makes your scans more accurate. So the higher your peaks are relative to your background, the better your composition measurements are going to be. So just for reference, right, here is our last scan in green, right, and here is the scan we just did in red. So generally, higher dead times not only allow you to take your scans and run them for shorter times, right, they also make your data more accurate. So I would always recommend having a dead time at least 10% if you can. Generally, if you have low dead times, it's okay. You just need to scan for longer to get similar accuracies because the peak to background ratio improves as you collect more x-rays. If you're scanning very, very small areas, right, very small volumes, say you're zoomed in, 10, 30,000, 10x, 10,000, 30,000 times magnification, your scan volumes are just naturally going to be quite small, so your dead times will be low. So that's okay, but just be aware that you might want to run your spectrum instead of for 30 seconds, maybe for a minute or 2 minutes, something like that. Okay, so that's the raw spectrum. We can now go to objects. Say we wanted to be more specific with how we collected data. So we go to our second button, which is object scan. Okay, for object scan, we're going to take our SEM image and we are going to select the regions to collect chemical data from. So we now have this new button, capture. If you do the drop down, you can capture the frames from your sample. So you can capture a single frame, a continuous frame, right? So basically just refreshes like the SEM, or an average frame. Continuous frame, I generally recommend because this will let you know if your sample begins to charge and drift, you will be able to see the image drift. If you do a single frame, the image drift, your sample could drift from underneath the beam while you're looking at it, right? And if your image is a little noisy, you could always switch to an average, in which case it will average multiple frames together, and that will reduce your noise a bit. But you see, here's our SEM window. Okay, here's our scan range. And I'm actually going to zoom in so we can get a little bit more specific with our compositions. Okay. So now that we've captured our window, we can now say where we would like to scan. So these buttons down here at the bottom, right here, are basically your options for scanning. So we have the first button here is called a point scan. That will collect the x-rays at a single pixel. So if I select right there, it will give me the spectrum right there. We also have an area scan, right, where you can draw a region and say, give me the composition of that region, right? And then we have a circular area scan down here, and then kind of a free draw or a grid of point scans, okay? Now, using the little arrow tool right here in the lower left, you can select which spectrum you would like to collect from, or if you have multiple spectrums, right, you're trying to collect multiple areas, if you hit select all, and then when you hit acquire and run the scan, it will collect both of those in series, okay? Now, I'm gonna run these for 30 seconds, right? These are smaller areas than before, so in reality, I should probably run these a little bit longer, but just to save time, I will select all, so I'm selecting both spectrums, and then when I hit acquire, it will scan spectrum 1. Oh, so I changed the magnification, so I need to recapture. So there we go. I will hit acquire, and then it will scan my 2 spectrums in series. Right, so it's starting with spectrum 1. You can see this labeled in the top right. And then once it's done, it will scan spectrum 2. So I'll go ahead, I can do auto identification, or sorry, auto scale. I'll bring up the periodic table. Right, we can do auto ID. There's also the element finder here, so if we were unsure what an element peak was, I can left click and put my mouse cursor over, and then in the periodic table, there's a little finder tab here, and it has a suggestion. It says, I believe that is copper, so we can add it, right? And then we can also add our silver. Okay, so it finished the first scan, and you can see the green line now is our second scan. Right? You can deselect scans down here on their labels by deselecting the arrow, right? So you don't have them overlap. Or if you just select both, right, they'll overlap on top of each other. Okay, my second scan is done, so I have both spectrums. So to get compositions, we select the scan down here that we want a spectrum from. So let's say I would like spectrum 2. I'm going to select that one. And then when we go to quantify in interactive mode, you can see at the top here, this is the quantification data for spectrum 2. Okay, so I'm going to clear all. I'm going to hit auto ID. I'm going to scale the background. And then generally I hit auto ID a second time. That sometimes identifies extra elements. And here we go. Here's our ratio. Again, copper, silver, and carbon. I would say I only want the copper silver, so I'm going to deselect carbon, and then this is kind of what I would record. So about 71% silver and about 29% copper. And again, I can save this, I can add this to the report. Okay, I'll go ahead and close this window. Let's say now, let's give me the composition for spectrum 1. All right, clear all, auto ID, auto background, auto ID again, and then again, compositions. You see for spectrum 1, we now have a different composition, about 91% copper, about 9% silver. And again, let's add this to the report. All right, I'll close this window, and if you even want, right, you see here we have the double back and forth arrows. We can add this image to the report, right? So we can tell people, you know, here is where I scanned, and here's where the data is coming from. Okay, for line scan, right, that is a series of point scans along a line, right? So this is basically just a more specific kind of object type scan, right? So again, we need to capture an image. So we can go ahead and hit capture. And then for this line, right, if you select this line, you can left click and drag, you can move it around. If you select the tips of the line, you can change its angle or its length, right? And what line scan does is it gives you the composition as a function of position along the line. So again, for acquire, we can go to measurement, and we'll run, again, let's do 30 seconds. There you go. And then we'll go ahead and hit acquire. And what we will see is it will identify the elements as a function of position. And right now it's not automatically scaling. So if you open this little guy and select automatic scale, there you go. So now it gives us composition as a function of position, right? And it gives us a line layer for every single element. So you see down here we have silver in blue, right? We have carbon in red, and we have copper in green, okay? And you can play with the scaling, right, however you wish, right? We can normalize it individually or to the highest profile. That way you kind of get a more referential, right? Our carbon is quite low. Copper and silver are quite high. And right, as we see, as we move across this line, right, we have this layered structure. We hit this region here, which is primarily copper. So we get a big green peak from copper, right? And then we kind of have back and forth this. Right, so again, from here, we have this back and forth arrow. We can save the profile, add it to the report. on this line scan, we can actually pull up the spectrum, right? So if we pull up the spectrum, and then on the left, we can pull up the line profile. And if you right click and drag, we can select the region we would like to get a spectrum over, right? So we have one for the whole range, or the whole scan, or a specific range, right? If we right click and drag in a very small region, we see the spectrum changes, right? Our spectrum changes as a function of our selection range. So we can get a spectrum from the whole thing by selecting all of it, right? Or we can get a spectrum just from a single spot. And again, depending on where you select, we have quantify, right? Interactive, and we can get the quantification for our selected range. So clear all, auto ID, auto background, auto ID again, and then again, compositions. So with the line scan, you also get a spectrum, or we can get this profile by switching between them here, right? And again, we can get a profile or the image, which again, we can save the image as well. Okay, the last one I want to show you is mapping. A lot of people use the mapping function. Okay, so mapping takes our SEM image, right, we see on the left here, so we'll go ahead and capture that guy. Again, we'll do a 10 frame average to reduce our noise a bit. So mapping takes the composition at each pixel and labels each pixel with the primary element detected. So the primary element will be given a color, and then that pixel will be colored in that color. So what we end up getting is we get a heat map, basically, of where each element is located in our sample, right? So we have a regular secondary electron image here. So we are going to go ahead and acquire a image. For mapping specifically, I tend to recommend higher dead times and longer scan speeds, or longer scan times. So for a regular spectrum or object scan, you can generally use lower dead times and still get pretty good data. But for mapping, it's very much based on the resolution of the image. So to get a good color match to your image, we generally do longer measurements. So I would at least double whatever time you were scanning with before to get a good map image, or increase your dead time by increasing your X-ray count. So I'm going to scan for 2 minutes, 120 seconds. We'll go ahead and hit acquire. And what you will see, right, is it gives us our secondary electron image. And then on top of that, it identifies the elements present, right? So we see we have our image, we have lots of copper, which it signs green in the dark regions, right? And then the lighter regions are mostly silver, blue, right? And also gives us carbon, which is just contamination, okay? Like with the line scan, we have a layer for every element, right? So we have our secondary electron layer, our carbon, copper, and silver. If we want, we can remove that by deselecting it, right? So let's say we just want copper, silver, or let's say we just want elements. We can actually deselect our secondary electron image, right? And just gives us our color map, right? Which sometimes is quite handy because the secondary electron image can interfere with it a tiny bit, or we can add it, right? So, right, we have our back and forth arrow here, right? We can save this image. We can add this to the report. We can also save these layers if you would like. If you can select individual layers, right? And you can save that, or if you don't select any of them, you can actually add all the layers, right? You said you did not select one image, you can add all the layers, or, right, we can just add copper, silver to our report as well, right? And if we open up our report window again, we'll see, right, we have all the data we've saved so far. Right, here's our map, here's all of our layers, right, when I added all of them, or we had just copper, silver here. Okay, now from this map, we can also, if you look on the top right, we can also get a spectrum, right? So we have a spectrum. If we open up the map part here, it actually acts like an object scan, right? We can take this and we can select a region. right? And we can get the spectrum for that region, right? We could also do a point scan, right? We could also do a line scan, right? And for every one, because it collects the spectrum at every pixel, we can figure out these different spectrums from our sample. And again, if we want composition, you just select the spectrum you want. So I'll select the map spectrum, which is the whole thing, right? We'll go to interactive quantify. And again, clear all, auto ID, auto background, auto ID again. And then here's our compositions, right? We now have some oxygen present. That's also a common contaminant. If we want, we can, all right, I'll raise the peak, I'll zoom in. You see we do have a little peak there. So there's probably some oxygen there. And I'll automatic scale back to here. All right, and that is for the map, right? If we wanted, say, this box that we drew here, we select that one, position one, hit quantify again, it gives us that composition. And we can always go back to the map and give us that as well. Okay, so that is the EDS program. So whenever you're done and you've saved your data, if you saved your data, right, you can just save it to the desktop or a flash drive or for that. If you have finished with the report, right, we go to these two back and forth arrows here. We export the report. And you can export it as a Word document or a PDF. I like Word documents, so I'm going to go ahead and export that. And depending on the size, it will take different amounts of time. So it's almost done. Okay. And then that Word document is opened. All right, and here's all of our data. All right, and now we can, right, you can save this or export it as a PDF, whatever you want. Okay. So that is the EDS software. So basically you want to control dead time and you want to make sure you're focused at a WD of around 15. Whenever you're done, you can just close the program and then log off the PC. And that is it. Go have fun.